Welcome to Maths for You channel. A past question on normal distribution from Oxford and Cambridge past paper. The screenshot in figure 10 shows the probability distribution for the continuous random variable x, where x normal distribution n mu lambda squared. The diagram given. The area of each of the unshaded region under the curve is 0.025. The lower boundary of the shaded region is at 16.452, and the upper boundary of the shaded region is at 21.54. Calculate the value of mu. Calculate the value of lambda squared. Y is the random variable given by y equal 4x plus 5. Write down the distribution of y and to find the probability of y greater than 9. Let's start the question. I just re-sketch the diagram given. The shaded region is between x equals 16.52 and 21.54. And the unshaded region is given in the portion is 0.025 each side. So that is 2.5% and 2.5%. So 5% unshaded. So the shaded region is 1 minus 5. So the whole area, normal distribution on the curve is 1. So 1 minus 0.95 is 0.5. That is given. So the 95% is shaded region. So the 95% is between x 16.452, 21.48. Do not look at the red ink at the moment. Just wait for us. Mu is the mean. It's always the normal distribution. Mu is the symmetry, or right in the middle of the bell-shaped curve. Mu is mean, and lambda is a standard deviation. The shaded region, as I explained to you, 1 minus twice 2 times 0.25. That is 1 minus 0.5. That is 0.95. That is 95%. Typically, it's just the normal distribution, 95% should be, is between the 2 lambda either side. So mu minus 2 lambda, mu plus 2 lambda, or mu minus twice as standard deviation, mu plus twice as standard deviation. So that is why I just put in the red, mu minus 2 lambda and mu plus 2 lambda, 2 lambda. So this the shaded region is 2 lambda, or 2 standard deviation between the 2 standard deviation. So mu, as I said, right in the middle of the bell shape. So right in the middle of that the shaded region. Therefore, the mu is just add them upper and lower limit and then divide by 2. So 21.548. So just 2 numbers. And you want to find the middle number, so add them 2 numbers. Say, for example, 4 and 5. You want to find the number. 4 and 6. You want to find the number between 4 and 6. So add them together. 4 plus 6 is 10 divided by 2 is 5. So just extreme values. Add them, divide by 2, give you the middle value. So 21.448 plus 16.452 divided by 2. Add them together is 38, divided by 2 is 19. So mu is 19. That's one of the question. Then, as I said, the region is between 2 lambda on the left-hand side and the right-hand side. So so the shaded region is mu plus 2 lambda minus mu minus 2 lambda. That is, we have, that's x value. That is, we have given 21.54 548 and minus 16.452. Left hand side 4 lambda, the right hand side 5.096. From that, lambda, or standard deviation, is divided by 4 is 1.27. For the calculation, I just took it as the one decimal place is 1.3 or two significant figures. So 1.3. Right. Next, so that is the both questions. The calculate lambda squared. So lambda squared is lambda squared equal 1.69. That is that's what we have to prove. Yeah, okay. Lambda squared found and mu found. The next question, why is the random variable given by y equal 4x plus 5? So I just 4x plus 5, a simple calculation, and write down the distribution of y and that. Okay, fair enough. The x's, this one, then y equal 4x plus 5. So it's just simply the y distribution, or normal distribution, 4 times 4x plus 5 times the n 19 and 1.69 lambda squared. And if you simply, the first one, 19, multiplied by 4 plus 5. So multiply by 4 is 76 and 5. And the other side is squared. So 4x squared, so 4 times 4 is 16. So 1.69 times 16. That gives us 27.04. Then from that, the final calculation, y, normal distribution, n 81, 76 plus 5 is 81. And I put it 5.2 in the standard form of lambda squared. So in other words, the mu is 81. Y, if it's distribution, if I want, I can sort of simple that. And that is 81. And this is when the lambda normal distribution 81 5.2 squared. So it's simply that is y. So this is mu. The new mu, the mu. I'll put it little y. That's it. Right. Okay. So we have found the normal distribution for y. Y normal distribution 81 the mu and 5.2 lambda. So the question asks us first is found that the y normal distribution. Then the question, find y greater than 90. Normally, the greater than, when you use the calculator, or when our calculation, we always have the find p probability y less than, or anything x less than, not greater than. So we know greater than. So say for example, here is 90. So 90, they ask us to find this bit, this shaded bit. That is obviously equal to this bit, non-shaded bit is 1 minus. So just the shaded bit we have to find. In other words, if you could find non-shaded bit and then take away from 1, give us the shaded. That is exactly what I did here. 1, because of the calculator to use, we can only find the less than value. So we find the less than value, and 1 minus give you the greater than value. So 1 minus probability y less than 90. Then use the calculator. Calculator, when you come to use the scientific calculator, you have to select the distribution, the normal distribution. You can see like a graph like that. You could see that on the calculator. So select that, and then normal CD, select that, or normally option 2, and ask you to put the lower value. Lower value always 0, put 0, that's the lowest, and the upper value is given 90, And mu we have found is 81, lambda is 5.2. If we put all these values, what we get for the probability of y less than 90 is this, 0.9582. That is 1 minus 0.9852. That is what we have to find. The value is 0. The probability of that 0.0417. So this is 0.0417. That's what it is. Thank you. Please subscribe to the channel and share this contents with your friends and other students, normal distribution. Thank you.